Hello everyone, welcome to this KANPUR-NPTEL course on space environment and its effects on orbital spacecrafts. So, in the last session we were discussing the segments of the satellite, and we discussed the different segments including the mechanical mainframe and electrical mainframe. And in electrical mainframe we covered the power system, then attitude and orbit control system, then telemetry tracking and the command, as well as the attitude orbit control system in the last session. We also discussed the different payloads which are used in the onboard satellites. So, today we will discuss a very important satellite segment, that is the earth segment. So, a satellite system without an earth segment will not work. So, the satellite system and its earth segments, it gives you a complete the link, or what you should say, this is the way a satellite can be operated. Without a ground station, satellite cannot be controlled, satellite cannot be monitored, that we have seen. That is when we discuss this telemetry, then tracking and the command, how a satellite health you can know through the telemetry, and then the command, this is if any corrections are needed, that can be done. So, we will discuss here the two types of the earth station. This is one is the receive only earth station, the other one is the transmit and receive earth station. So, what is basically an earth station? So, earth station is the terrestrial terminal station, mainly located on the earth's surface. Of course, it also include in the earth segment those stations which are on the ships at sea, or it can be in the commercial, military, aeronautical mobile stations, means those stations which are on board a aircraft. So, the earth segments of the satellite communication, it mainly consists of two types of earth stations. So, these are the transmitting earth station and the receiving earth station. So, it is very much clear that a transmitting earth station transmits the information signals to the satellite, whereas the receiving earth station receives the information signals from the satellite. Sometimes, or in most of the cases, the same earth station can be used for both the transmitting and the receiving purposes. The simplest of these are the home TB receive only, this is the TBRO systems, and the most complex system are the terminal stations which are used for the international communication networks as well as the deep space network. So, this earth station functions used for the logistic support of the satellite, as for example, such as those for providing the telemetry, tracking and command functions are also considered as a part of the space segment that already you have seen. So, let us discuss the earth station and the satellite, how these are connected. So, you see in this illustration two earth stations are there. So, when a earth station communicates with the satellite, it sends a signal that is called the uplink. So, this uplink signal is sent, and then the satellite will process that signal, that is that signal will be translated to a downlink signal, and that can be sent to another earth station or to the same earth station. It is possible both way. Okay. So, there is only two earth stations are shown, there can be the multiple earth stations, and through the earth station. So, one earth station can communicate with the earth station via this with the satellite. So, there will be the uplink, and by the downlink signal, the signal can be transmitted or communicated to the other earth station. Okay. The other example can be, there can be here it is shown one satellite and multiple earth station. It can be multiple satellite which is communicated by a single earth station. So, this shows this illustration. So, basically then this radio link, what is important to connect a satellite from the ground station, this is basically a radio link, or it is a wireless link between the transmitting earth station and or a receiving earth station through the satellite or multiple satellites. So, as we know, there are the three essential elements of any satellite communication or any type of satellite network system, that includes the earth segment and the space segment, and this uplink and downlink between the space segment and the earth segment. So, these are essential for any type of satellite application. Now, let us just try to see what are the earth station configurations. So, any earth station configuration, it is mainly governed by the type of the service which is provided. So, it can be the fixed satellite service. So, what is fixed satellite service? So, the stationary ground equipment at predefined locations, it is not mobile, at predefined locations for both transmitting as well as the receiving signals, receiving the satellite signals. And this category includes a wide range of services. It can be international internet connectivity, or it can be the business networks like banking, share market. There are so many different types of networks which comes under the category of this is the fixed satellite services. So, this illustration shows this. So, you can see this is the fixed satellite service, the transmitting earth station, and then this is this shows a receiving earth station, that is FSS receiving earth station. It can be multiple satellites as well as it can be multiple earth station also. So, here it shows one earth satellite and one earth station and one transmitting station and one receiving station, but there can be the same earth station which can transmit as well as they receive, as we discussed previously. Now, the second category is broadcast satellite services or BSS. So, these are suitable for the reception using compact ground equipments, and the most well known applications include direct to customer or direct to home, this is the television, and the broadband services. So, you can see these are called the VSAT, very small aperture terminal, and this shows this is mounted on the roof of a house, it can be mounted on the wall also. So, this category comes under the broadcast satellite service. The third one is mobile satellite service, MSS. So, what is MSS? So, MSS employs the transportable receiver and transmitter equipment. So, this serves as the mobile, it can be mobile on the earth surface, it can be on the sea, that is the maritime, that is the applications over the sea, or it can be on the aircraft, that is the aeronautical customers. So, it ensures the communication connectivity while the users are on the move. So, you can see that is an earth station mounted on a vehicle. Now, what are the important earth station parameters? So, again here the question comes the quality of the service. So, quality of the service are dictated by, that is called the earth station G by T. So, what is G? G is called the gain of the antenna. So, now what do I understand by the gain of an antenna? So, gain of an antenna, if I say the G, this is the gain of the antenna. So, here this eta is called the efficiency and A is the aperture of the antenna, this is the dimension, or you can say this the aperture is the best term to use, and lambda is the frequency at which the electromagnetic signal is transmitted or received. So, basically this what is the gain of the antenna? Gain of the antenna is the capability to focus the electromagnetic radiation in a particular direction. So, you know an antenna pattern can be this is the way one can be pattern, another pattern can be like this or it can be like this. So, depending on what is the antenna gain, this is the more the gain, this the antenna pattern will be more pointed. Okay. So, by the gain of an antenna, I understand that is the focusing capability of the antenna over a particular angular region, over the desirable angular region. So, this is called the gain of the antenna. And what is the T? T is the equivalent noise temperature. Why equivalent noise temperature? Because when an antenna is looking to the sky or to the earth, it receives electromagnetic signal other than the desirable signal. So, you can that whatever that signal you receive, then you can represent it by KTB. So, this T is called the, so this energy you can write in terms of the or the whatever the undesirable energy, this can be represented by the T. Also there are the noise sources in the receiver itself. So, this all these things are represented by the equivalent noise temperature. Now, the type of communication requirements. So, it can be telephony, it can be data or televisions. Then what is the international regulations? So, there are few international regulations like what should be the, that is the interference, or the the antenna will have a main lobe and it will have the side lobes. So, there will be the regulation, international regulation, that you cannot go beyond this side lobe. So, this is called the ITU regulations. So, all these regulations whenever a earth station is designed, this has to be kept in mind. Then it comes the cost consideration and site constraint. Site is also very important here. So, again it depends on the applications. So, whenever very large earth stations are installed, so the cost considerations comes into picture, as well as for for when we consider a very small terminal, the B set, then also the cost is very important, where I am going to install it. For big earth station, the site constraints are also there. What is the soil quality and where exactly we are putting the antenna, so that the field of view is clear or not. So, all these things, the site constraints come into picture when we are to decide a particular earth station. And the earth station is also characterized by the frequency. What is the frequency? These are all the communication frequency band. This is the C band, this is the Q band, there can be the other band also, K band, Ka band, all those bands can be possible. Accordingly, the earth station has to be designed and has to be developed like that. Then polarization. So, any electromagnetic signal will have the polarization. There are two types of polarization, the linear polarization and the circular polarization. What is linear polarization? Linear polarization means this tip of the electrical vector that is oriented in a plane. So, it can be linear polarization can be B or it can be H. This is the linear polarization. Whereas circular polarization it can be LHCP or RHCP, means left hand circular polarization or right hand circular polarization. Then antenna diameters. So, basically when I need this is a very high gain antenna, so the antenna diameter will be higher and higher, and this again it will have an implication on the cost. Of course, whenever the requirement is there, that is you want to have a very high gain antenna, the antenna diameter can be something like 11 meter, it can be 13 meter, it can be even up to 30 meter. Now, another very important parameter is called the effective isotropic radiated power, which is the transmitted power as well as the gain. What is the power you are transmitting and what is the gain of the antenna? So, when we make this product, this is called the EIRP. Then what is the gain of the receiving antenna? That is also very important, and we will see that all this parameter that will finally give me an idea what is that signal level I will be able to receive it. So, this is called a link margin or the link calculation. So, that will come when we proceed further. Then what are the modulation types you are using? So, different types of, whenever we do an wireless communication, we need to have the modulation of the signal. So, there are different types of modulation like analog modulation, amplitude modulation, frequency modulation, phase modulation. In the digital communication, we will have amplitude shifting, then frequency shifting, phase shifting, then quadrature amplitude modulation. So, there are different types of modulation and different types of access methods, that is called the multiple access bands, that is multiplexing the different users, the different channels. So, this is called the access method. So, there can be FDM, that is the frequency division multiple access, time division multiple access, even the another type of is the code division multiple access. So, there are so many types of the multiple access. So, that also need to be considered. Now, let us discuss what is called a single function stations. So, single function stations are characterized by a single type of link. So, single type of links means either it can be one satellite or can be a constellation of satellites. So, these stations may be just transmit only or receive only. So, some common examples of single function stations are the television receive only, that is TVRO terminals, which are used for the TV reception by an individual satellite radio terminals. So, this type of antenna as are seen, generally these are used widely in offices or in homes to have a direct to home satellite services. So, this receive only home TV system. So, these are planned broadcasting directly to home receivers, which takes place in the Ku band. So, here going for a higher frequency band is that whenever I go to higher like Ku band, my antenna size will be this smaller, because the higher the frequency, the lower will be the wavelength. Okay. So, this is known as direct broadcast satellite service. When you directly it is taken to home. So, these are called the direct broadcast satellite service, and the frequency bands of those DBS satellite service, it varies depending on the geographic regions, and about 75 Ku band transponders from the different the GSAT series of satellites. These are catering to this DTH television services, and more than 40 million DTH connections are subscribed to various DTH television providers. Now, there is one type of art station that is called the gateway art stations. So, what is the gateway stations? This is also referred to as teleport or hub stations. So, these serve as an interface between these satellites and the terrestrial networks, all the local area networks. So, there can be a network which is connected by it can be a wired link or it can be a wireless link, and then this gateway station receives a large variety of terrestrial signals at any given time from all those terrestrial terminals. And so, this include telephone signals, then television signals, or it can be the broadband, then it can be data streams and so on. So, these stations are connected to the terrestrial network by various transmission technologies. So, there are two types of technology. One is the wired. Wired means using the cables. So, it can be coaxial cable, or it can be optical fibers, or it can be wireless. Wireless means whenever we use, there is the microwave towers, and from using that microwave towers. So, microwave tower can become one node of that terrestrial or the local area network. So, there are advantages and disadvantages of both the types. So, unlike the single function art stations, where it is just uplinking and downlinking separately operations through that, but here in the gateway stations, signal processing is the major activity. So, getting the signals from different nodes of the terrestrial network or the local area network, and then multiplexing it and connecting it to the satellite. So, a lot of this type of signal processing need to be done in a gateway station. Now, let us see the art station architecture. What are the blocks that constitute the art station? So, first is called the broadband, the baseband section. Now, what is the baseband? By baseband, I understand it is the low frequency. So, generally like a video signal or the voice signal, they are called the baseband signal. That is the frequency band is in the frequency band, like if I consider the audio signal, then it will be something like 30 hertz to 20 kilohertz. So, this is called the baseband signal, and so this art station will first consider a baseband processing circuit. So, what is a baseband processing circuit? So, baseband signal in this section, the signal will be processed, or maybe if there is any noise, so those noise will be by using proper filtering, this noise will be removed, or there can be some signal conditioning or signal conversion like analog to digital conversion. All these things will be made in these sections. Then comes a section that is called or a block that is called the modulator. So, modulation is very important, because the baseband signal we cannot transmit it through any wireless mechanism, because in that case the antenna size will be very big, and at the same time we need to separate the signals. So, separating the different signals, we need the modulations. So, in art station, this modulation, this baseband, the signals at the baseband frequency are converted to intermediate frequency to this modulator, and then it is sent to the RF section. This is also called the the passband section. Passband means high frequency. So, here there is an up converter. So, what is up converter? So, this using this modulator, of course, this is also up converter, but here we do up to the IF, and then the up converter converts to that frequency which is will be very suitable to transmit using an antenna, that is the earth station antenna. So, after this up conversion is done, then the signal is amplified by using the high power amplifier, and then the signal is transmitted using this antenna. So, this is the chain of the, or this is the block diagram of the transmitting section. So, this is the uplink signal. Now, whenever the earth station receive a downlink signal, so that downlink signal is first a low noise amplifier is used, because the satellite travels a large, the signal travels a large distance. So, its signal level is very tenuous. So, in that case what is needed? A low noise amplifier. This is the type of amplifier which will not add the noise here. So, that is why it is called the low noise amplifier. That is, that signal to noise ratio has to be very good for this type of amplifier. So, that I can amplify a very tenuous or very weak signal. So, once this is done, then it is down converted. So, all the process what was done during the transmit change, that has to be reversed. So, the down conversion is done. After the down conversion, then it is again done the demodulation. Once you do the demodulation, then we reach to the again the baseband where the information is contained. Now, there is a terrestrial interface. So, terrestrial interface there, you know, whatever this voice signal, video signal, all these things are taken from there, which is processed here and then transferred to the baseband processing circuits. And each earth station also needs some support facilities. So, it can be, you know, the environmental conditioning like air conditioning. So, this earth station should be protected from the environment. Then you need a monitoring and control system, and then the power supply. So, each part again in the next slide I will try to explain. So, what is the base? This is the baseband equipment, already we explained. Then the RF section, then the terrestrial interface. So, what is the baseband section? It performs the modulation and demodulation functions with the specific equipment depending on the modulation technique and the multiple access method employed. What is RF section? So, RF section does the up conversion, then it includes a high power amplifier and an antenna subsystems. So, this is in the uplink or in the transmitter channel, whereas in the receiver channel this will again an antenna subsystem, then low noise amplifier and the down converter and the downlink channel. What is the terrestrial interface? So, it may be connected directly to the user in some applications. So, the terrestrial network couples, it could be a fiber optic link or a microwave link or even the combination of the two. So, then the earth station has few support facilities, as I already said. It has to have a stable power supply unit with adequate backup, then monitoring and control equipment, then thermal and environment conditioning unit, that is it can be required the heating or air conditioning, etc. So, this already I told you. So, if we whatever I said here, this has been shown in this block diagram, which already was explained in the previous slide. So, what are the performance parameters of an earth station? So, this is the ARP, then the figure of merit already I said, and then ARP, that is the effective or the equivalent isotropic radiated power. So, what is written here? It is a high power amplifier HPA and the transmit antenna. So, this will give you that. Then it is given by the product of the transmitted power and as well as the gain of the transmitting antenna, and these are expressed in decibel. So, decibel means you are putting 10 log and then that quantity. So, this is the expression for when I express any quantity. It can be ratio of two quantity or directly also I can put only P, then it will give me in decibel. So, this is called the decibel or dB. So, ARP is defined for both the earth station transmitting antennas as well as the satellite transmitting antenna. So, this receiving antenna figure of merit is a G by T. So, it tells us the sensitivity of the receiving antenna and the low noise amplifier LNA combined to the weak received signals. and it is the ratio of the receiving antenna gain. So, this is the G and system noise temperature, this is T and this is G, and the G by T is expressed in dB per Kelvin. So, the G by T of earth station, it can be enhanced by increasing the receiving antenna gain or by lowering the noise temperature or both. Okay. So, now we will discuss that is how this that is the G by T is actually it is estimated. So, this is the expression, we have not derived the expression, but it comes from the Friis transmission formula, that is when you are having two antennas transmitting and receiving antenna, and if you know what is and considering a transmitted power, then what is the path loss, considering both the way path loss, we can calculate the G by T using this expression. So, what are the figures here? So, this C by N0 that is carrier to total noise power per unit, that is called the spectral density, that is the per unit bandwidth. Then AERP already I said what is, this is isotropically radiated power loss, and then LP is the link margin, sorry, LP is the path loss, this is the path loss, and LM is the link margin, K is Boltzmann constant 1.38 into 10 to the minus 23 joule per Kelvin. So, based on this link calculation, the transmit and receive channel can be optimized by two various trade-offs based on the actual requirement. So, what is the complexity and cost issue? This depend on the earth station AIRP, then antenna tracking requirements, what is the traffic handling capacity, and then what is the terrestrial interface requirements. And in addition to all these things, there are also this international regulatory issues which I discussed about the side lobe and the other things, and these are the constraints and which has to be considered while optimizing the particular earth station. So, in this lecture we have just tried to discuss the different aspects of the earth station. So, we discussed two types of earth station, this is the both the transmit and receive, and this is the only receive. And we discussed the that is the performance parameters as well as the different configurations, different types of, and what are the important parameters which decides the performance of a earth station. So, let us end here. Thank you very much.